In this lab, we'll take a look at a local file inclusion vulnerability in Gila CMS and see how this vulnerability can be used for remote code execution. The first thing that we'll want to do is make sure that Burp Suite is up and running. To do this, click the system icon in the top left corner, search for Burp Suite, and then click it to start it. There'll be a few dialog options. Feel free to click OK and accept defaults for these. If it asks if you'd like to update, click Close. Once Burp Suite has finished loading, we'll need to turn Intercept off for now. Click the Proxy tab, and then click the third button so that it reads Intercept is off. Once that's done, we can launch Firefox and configure it to use Burp as a proxy. Launch Firefox in the same way that we launched Burp Suite. Once Firefox is loaded, click the three bars in the top right corner and click Preferences. This will open Settings. Scroll down to the bottom of the General section and click Settings. Then set the manual proxy so that the HTTP proxy field reads the local host address of 127.0.0.1 and the port is set to the default Burp proxy of 8080. Click OK when you're done. Firefox should now be configured to use Burp as a proxy. Let's now navigate to Gila CMS. You can do this by going to the URL of gila.ii. Cool, we can see Gila CMS. Now let's navigate to the admin panel. Do this by adding a /admin to the URL. From here, we can log in as the admin user. The email is admin@gila.ii, and the password is simply the word admin. Go ahead and log in. Now that we're in the admin panel, we can take a closer look at the vulnerability. The vulnerability revolves around deleting posts. Go ahead and click on this green tile to go to the post management view. At this point, we'll want to turn proxy intercept back on in Burp Suite. Go ahead and click on Burp Suite again, and then click this button once again so that it reads Intercept is on. This will capture all web requests so that we can take a closer look at them and edit them as we need to. Now that Intercept is on, go ahead and click on the trash icon for this post, and click OK to confirm that you'd like to delete it. Cool, Burp Suite captured the request. At this point, we can take a closer look at the actual request that was sent. A post request was sent to /cm/delete with a get variable of t, or type, set to post. Let's send this to repeater so that we can edit it a little bit easier. Click Action, and then click Send to Repeater. You can see that the repeater tab lit up, so we can click on this now to go to it. The local file inclusion vulnerability in Gila CMS revolves around faulty types. When a type is set to the location of a file on the server, that file's contents will be included in the response. To test this out, let's remove the text post and instead include the location of the etc password file. We'll need to move up several directories, so include 3 .. slashes. After this, type etc/password. Once you've finished doing this, you can click Send, and as long as we've done everything correctly, the contents of etc password should appear in the response. Fantastic! We can now see the contents of etc password, letting us know the users and their respective groups just from a local file inclusion vulnerability. Being able to read arbitrary files on the server is great, but we'd like to be able to execute code on it as well. To do this, we'll need to edit and upload a reverse shell, and then use our local file inclusion vulnerability to execute that reverse shell. The first thing that we'll need to do is grab a copy of the reverse shell we'd like to use and edit it so that it'll work for us. Open a terminal by clicking this icon in the top left corner, and then navigate to the home directory by typing cd. From here, we'll copy a built-in reverse shell so that we can edit it. Type cp, then user, share, web shells, php, php-reverse shell.php. In order to edit this file, we'll need to know our IP address. Open up another terminal, and then type IP space A. This will give us our current IP address, which for us looks to be 172.20.0.2. Open up the reverse shell in an editor of your choice. I use Vim, feel free to use whatever you'd like. Scroll down a little bit until you see two lines that have a change this comment. We'll need to edit the IP so that it matches our IP and the port to a port number of our choice. Once you're done, go ahead and save that file. We'll now need to upload this file onto the server. If you haven't already, turn off intercept. This will allow us to browse around on the web server without burp getting in the way. Go back to the admin panel and under Content, click on Media. Then click Browse, Home, and All Files. This will allow us to select our reverse shell. Now, when you click Open, you'll notice that you get an error. Gila CMS is smart enough to realize that this is not a media file and doesn't accept the upload. We'll need to trick Gila CMS into thinking that we're uploading a reverse shell. In order to do this, all we need to do is create a copy of our reverse shell with a valid media file extension. For this example, I'll use JPEG. Once you've done that, click Browse again, select our new fake picture, and upload that. Awesome. We can see that our reverse shell has uploaded. Our next step will be to create a netcat listener so that when we execute our reverse shell, we can capture the incoming stream. Type nc for netcat, then -nvlp, and then the port that you chose earlier. Go back to Burp Suite so that we can execute our local file inclusion on our reverse shell. Click on Repeater, and under Type, we'll need to put our reverse shell's location here. This should be // assets / the name of the file that you've uploaded. In our case, it's php-reverse shell.jpg. Once we send this, with any luck, we should get a reverse shell back in our window. Click Send, and take a look, and we have received the reverse shell indeed. Awesome. We can go ahead and type ID and host name to confirm that this is in fact on the remote server. And with that, we have remote code execution using a local file inclusion vulnerability.